Hi, my name is Cody, and today we will be discussing AppArmor and HTTPS protocol. First up, we've got a little bit of a table of contents here with an introduction, quickly showing what we will be discussing throughout this presentation. As a quick introduction, this presentation delves into the critical aspects of enhancing system security using AppArmor and the HTTPS protocol. It covers AppArmor, a powerful Linux security module, and its significance in protecting applications through mandatory access control. Additionally, it explores the HTTPS protocol, ensuring secure communication over the internet, along with specific hardening recommendations for IIS on Windows and Apache on Linux servers. Together, these tools and practices offer a comprehensive approach to fortifying systems against potential threats. First off, we've got AppArmor. AppArmor is a Linux kernel security module that allows system administrators to restrict programs' capabilities with per-program profiles. It supplements the traditional Unix discretionary access control, DAC model, by providing mandatory access control. AppArmor profiles define what files and capabilities a program can access, helping to prevent unauthorized actions even if there are vulnerabilities in the program. Interestingly enough, AppArmor is easier to manage than SE Linux because it uses path-based profiles, making it simpler to configure and maintain. Here we've got a graphic. I thought I came across this while doing some research and thought it was a really solid graphic, kind of helped me understand things a little bit more, so I wanted to include it on this presentation. It's a flow chart that illustrates the AppArmor security and kind of the process for handling system calls in a Linux environment. Depicts how a user-level process makes a system call and then looks up an enode. The process undergoes various checks, including an initial error check, a discretionary access control check, and a Linux security module interface check. If access is allowed, AppArmor consults its application profiles to decide, and the result is returned to the user-level process. So here we've got some hardening recommendations for AppArmor. Few solid things to consider would be enabling AppArmor by default. It sounds pretty simple, but it's often something that can be easily overlooked. So you want to ensure that AppArmor is enabled and running on your system. Then you've got create and enforce profiles. So develop AppArmor profiles for critical applications and services and ensure they are in enforce mode. And then as finally, you want to keep profiles up to date to adapt to new threats and changes in any application behavior. The command to check AppArmor status is actually going to be sudo aa-status prompt. This command will provide a detailed view of the current state of AppArmor on your system, including the number of loaded profiles that you are running. Next up, we have HTTPS protocol. It is simply an extension of HTTP, a little bit more secure though. It's used for secure communication over a computer network and is widely used on the internet, especially today, pretty much everywhere. HTTPS encrypts the data exchanged between the client and server, ensuring data integrity and privacy. A quick key fact is HTTPS protocol not only encrypts the data transmitted between the client and the server, but also helps boost a website's SEO ranking. Search engines like Google give preference to secure websites, So using HTTPS can improve your site's visibility and search engine ranking. A little bit more on HTTPS protocol. The encryption, HTTPS uses SSL or TLS protocols to encrypt the data transmitted between the client and the server. This prevents unauthorized parties from intercepting and reading the data. You've got authentication as well. HTTPS requires a digital certificate issued by a trusted certificate authority to verify the identity of the server. This ensures that clients are communicating with the legitimate server. You got data integrity. HTTPS ensures that the data sent between the client and server is not tampered with or altered during transmission. And then finally, secure handshake. HTTPS initiates a secure handshake process that establishes a secure session key for encrypting data during the communication session. This is also another graphic that I was a fan of, kind of helped explain things a little bit more clearly in between HTTPS connection and just your basic HTTP connection. It compares both connections. It shows that an HTTPS connection is secure, encrypting data transmission to protect it from outside access, while a basic HTTP connection is insecure, leaving data in transit vulnerable to the man-in-the-middle attacks. The icons represent the customers and the web servers, with a green lock symbol for the HTTPS showing secure transmission, whereas the HTTP connection is simply insecure. This pretty much highlights the main difference in the security between the two protocols. It definitely emphasizes the importance of using HTTPS as it is more secure. Hardening recommendations. So we've got IIS for Windows Server, if that's what you're running, and then we've got Apache on Linux. So on the Windows Server, you want to enable HTTPS. Again, this is fairly basic, but it's also something that can be easily overlooked. So you want to make sure that it's enabled and properly configured on your IIS server. You want to use strong encryption. You want to configure IIS to use strong encryption algorithms and certificates. And then, of course, you want to regularly update and patch. So you want to keep the IIS server on Windows and its components up to date with the latest security patches, which do fairly come out often. And then over on Apache with Linux, again, you want to ensure that HTTPS is enabled and properly configured on your Apache server. As well, you want to use strong encryption as well. Here you want to configure Apache to use strong encryption algorithms and certificates. And then again, you want to regularly update and patch. You want to keep the Apache server and its components up to date with the latest security patches. For the summary for this presentation covered the importance of enhancing system security using AppArmor and HTTPS protocol. AppArmor is a powerful Linux security module that enforces mandatory access control through profiles with key commands and hardening recommendations highlighted. The HTTPS protocol ensures secure communication over the internet, and we also discussed specific hardening practices for both IIS on Windows and then Apache on Linux servers. Together, these tools and practices form a comprehensive strategy to fortify systems against any potential threats. Then here we've got the Works Cited page. As far as references go, I found a lot of great information on the Linux kernel documentation website for AppArmor. There are plenty of great websites for checking on how to check AppArmor statuses, which is something that I kind of struggled with in the beginning, as well as understanding the AA status command in AppArmor. I included that in the fourth reference, if you can see right there. That link will take you there. It also has examples on how to check, which I found is great. And then a big thing that I found important when considering too is the Google HTTPS ranking. Why SSL is so good for SEO. That's a great website to check out. It kind of really shows the importance of using secure transmission nowadays. And then finally at the bottom, these two I found great. The Apache Web Server Hardening and Security Guide kind of gives you a quick rundown of what Apache is and how it works on Linux. And then it's got great security hardening tips, which has been recently updated, I believe, as in the last quarter of 2024. So all in all, some great websites and references to check out. Thank you for watching.